This thing on? I can't tell. I'm a sound guy. I don't know how to work these freaking. Hello, YouTube. Welcome to the Production Institute. It's been a while since I've been able to make videos. The Georgia Theater, where I worked for so many years, burned down in June 2009, and we're in the process of rebuilding it right now. So today, what I'm going to talk about, what a lot of people often ask me about, is wires, how to fix their cabling, and how to fix mic wires and things like that. And so I thought the best thing to do would be to start with the basics, because one of the first things a sound engineer needs to learn about is wires and how the different ones work, and what wire you use for what wire to not use, especially. And signal wires kind of come in three flavors. I have three different flavors of wire here. All three of these are balanced cables. That's where the similarity stops. In these wires, the differences really lie in the type of shield that they have. If some of you have watched my other videos about common mode rejection in mic wire and how to properly wind a mic wire so that it doesn't destroy that common mode rejection, this is why. Or I'm about to explain why, a little bit more detail as to why. This is probably the cheapest wire there is. This is commonly referred to as 291. It's pulled inside of conduits, and in the old days it was commonly used in snakes. As maybe as you can see, it's hard to see, but basically you have two conductors. You have the two conductors, a foil shield that wraps around the conductors, and then a drain wire that's outside of the shield. And that shield wraps around there, and it does a pretty good job of rejecting common mode noise, like RF and what have you. The real issue with it is that if this ever bends while there's signal running through it, somebody were to step on it, or you bend it suddenly, it's going to make a high frequency noise. That's because the capacitance in this foil changes as it moves. It's not steady, it's not static. And as that capacitance changes, it induces a change in the conductors. And that manifests itself as a high frequency click or pop. And you can hear that in old snakes when you move them around. So this stuff is only used to be put in the wall in a conduit and connected in it, as long as it never moves or gets severely bent or what have you, then it stays noise free and it has good rejection. It's known as 100% rejection. The next type of cable, and this is the cheapest, about the cheapest cable you can get. The next type of cable is you could use for a mic cable, but you probably wouldn't, because again, it still has a foil shield. You can see on this end, it has a braided copper shield on top of a foil shield. And this gives it even better noise rejection. But still, because of the geometry of the shield, and it is prone to making high frequency noises if it's stepped on or bent suddenly or any of those things. And so again, it's generally used for more high-end applications. This is more of a studio quality wire for installation. So it's just a little bit more expensive than the cheaper stuff. Then you have the really high-end stuff. That's mainly used for mic cables. And we have, just to remind you about the shield, you have a foil shield with a drain. It's just simple foil and drain wire. Then you have a foil shield with a braided copper shield on top of that, so the rejection is better. Combination hybrid. And this is known as a served shield. And a served shield is impervious to noise when it's bent or stepped on or kinked. It's still important to wrap it correctly. It may be hard to see on the camera here, but it is, the shield is made up of individual wires. I'll pull this shrink that I put on here earlier off there. And they're laid side by side and wrapped with a twist. And this again is all the more reason to take care of your mic wires carefully and wrap them carefully, and not put kinks, not use technique of tying them in knots, because you are kinking shields and putting gaps in the shields, and therefore anywhere there's a gap, RF can get through. And so if you have a bunch of kinks and a bunch of small kinks in a long cable, it just means that cable is noisier and more prone to noise, inducing noise from stepping on it, or somebody picking it up. Say if it's on a handheld microphone, you're moving around, you have one of these cheaper cables, you're going to hear clicks and pops. With this served shield mic cable, you won't. It's impervious to that type of noise. That's the real difference between the three types of shields you have. You have a served shield, you have a simple foil shield with a drain wire, you have a copper braided shield. Oh, I'm sorry, I got those backwards. That's the simple shield with a drain wire. This is braided copper over a foil shield, which is better rejection. And then you have a served shield, which is the proper way to shield a cable that's going to be moved and handled a lot. There's your lesson today on cable shields. Next lesson, we're going to talk about how to prep these wires, how to take these wires and prep them correctly to either put mic cable ends on them, or guitar cable ends, or the various things that you need to solder together. And we'll talk about solder and the tools you need, and the proper way to do it, the proper way to inspect it to make sure that your solder joints are actually correctly done. There you go.